Hello, in this video we're going to look at algebraic proof. So here's our first example. It says prove that x plus 10 all squared subtract x plus 2 all squared is divisible by 16, where x is a positive integer. So what I'm going to do is I'm going to expand this expression and simplify it and see what we get. So x plus 10 squared. Well, x plus 10 squared would be the same as x plus 10 bracket x plus 10. Because whenever you square a bracket, you're multiplying it by itself. So I tend to write it out twice like so. And subtract, and then again, x plus 2, bracket x plus 2. Because you're squaring the bracket, you're multiplying it by itself. Now we're going to expand these brackets. So x times x, well that's x squared. X times 10, well that's plus 10x. 10 times x, well that's plus 10x as well. And 10 times 10, well that's 100. And we're going to be subtracting. Now I'm going to put, whenever I expand these two brackets, I'm going to keep my answer in one large bracket, okay? So x times x is x squared. X times 2, well, that's plus 2x. 2 times x, well, that's plus 2x. And 2 times 2, that's plus 4. And whenever you simplify that, that will give us x squared plus 20x plus 100. And we're going to be taking away, and this is why I've written it in a bracket so we can just see what we're going to be subtracting, x squared plus 4x plus 4. Now, let's simplify it. X squared take away x squared, well, that's 0. 20 take away 4x, that's 16x. And 100 take away 4, well, that's going to be plus 96. Now, we've been asked to prove that this is divisible by 16. So we need to show this expression here is divisible by 16. So to show it's divisible by 16, what we're going to do is we're going to take 16 out as the common factor. So we're going to factorize it. So 16 bracket, and that would leave us with x plus 6, factorizing it. Now here we've got 16 times. Now keep in mind x is a positive integer, so this value for this bracket here will be a positive integer, and we're timesing it by 16. Well, if we do 16 times anything, that's going to be in the 16 times tables. So that means it is divisible by 16. So therefore, divisible by 16. And that's it. Now what we're going to do is we're going to look at in some questions, rather than giving us the expression, if you look at this in this question here, they gave you, the question had given us the expression and we had to prove that it was divisible by 16. In some other questions, what they do is that the question will ask sort of things like this: prove the sum of 3 consecutive even integers is divisible by 6. So to do that, we need to know how to write expressions for some key or some common terms that they will use in algebraic proof questions. So first of all, an even number. Now, an even number, well, any number in the 2 times table is an even number. So in algebraic proof questions, if you've been asked to sort of use or talk about even numbers, I would use 2n to represent any even number. Okay, so an even number, I would use 2n because it's 2 times a number. Now remember that value for n could be even or odd, but if you times it by 2, it will always be even. Next, an odd number. Well, if we know that 2n is an even number, if we add 1, we're going to get an odd number. So personally, I use 2n plus 1 to represent odd numbers in questions. Okay, or just add one odd number in a question. Okay, next, 3 consecutive numbers. Well, if we're talking about 3 consecutive numbers, well, they haven't specified whether it's even or odd. So what I'm going to do is I'm just going to use n to represent any number, n plus 1 to represent the next number, and the next number would be n plus 2. And that would be 3 consecutive numbers, 3 numbers that are next to each other. So they run consecutively, n plus 1, and n plus 2. Next, 3 consecutive even numbers. Well, as we've seen earlier, 2n is an even number, so let's use 2n for our first even number. Now, if we added 1, it would be odd. So what we're going to do is we're going to add 2 to get the next even number. And then adding 3, again, that would be odd. So if we add 4, that would be the next even number. So 3 consecutive even numbers, well, 2n, 2n plus 2, and 2n plus 4. Next, 3 consecutive odd numbers. Well, as we've seen, 2n plus 1 is an odd number. So I'm going to use 2n plus 3 to be the next odd number, because 2n plus 2 would be even. So 2n plus 3 is the next odd number. And then 2n plus 4, again, that's even. So 2n plus 5 would be the next next odd number. So that would be 3 consecutive odd numbers. Next, 2 even numbers. Now, in this we've been asked here to write 2 even numbers. Well, first of all, an even number, we're going to write 2n. Now I'm not going to write 2n plus 2 for the next even number, because it doesn't say 2 consecutive even numbers, it says 2 even numbers. So for instance, one could be 4 and 1 could be a million. So what I'm going to do is for the next even number, I'm going to use 2m. And that way we know that we've got two even numbers. We don't know what they are, but at least we know they're not consecutive, or they don't have to be consecutive. So we've got 2n and 2m. And two odd numbers, well again, 2n plus 1 would be an odd number. So 2m plus 1 would just be another odd number. And there we go. So here we've got some very common terms that you will see in algebraic proof questions, and this is how we would represent them. Okay, let's have a look at a question then similar that would use these. So the question says, prove that the sum of three consecutive even numbers is divisible by 6. Well, as we've seen earlier, well, an even number, let's go for 2n, where a sum means we're adding them up, so plus the next one, well, that would be 2n plus 2, and the next one, that's going to be plus 2n plus 4. Now when we add them up and get the sum, that would be 2n plus 2n plus 2n, that's 6n. And then in terms of the numbers, we've got 2 plus 4, well, that would be plus 6. So the sum of three consecutive even integers would be 6n plus 6. Now to prove it's divisible by 6, again I'm going to factorize and take 6 out. So that would be 6 bracket n plus 1. Now that's 6 times something, well therefore it's divisible by 6. Okay, next question. This question says, prove the product of two odd numbers is always odd. So now this question, it doesn't say two consecutive odd numbers, it just says two odd numbers. So I'm going to let the first odd number be 2n plus 1, and I'm going to let the second odd number be 2m plus 1. Now the word product means we're going to multiply them together, so we're going to times these together. Whenever you times them together, well, I'm just going to move that across, and now we're going to expand it using FOIL. So 2n times 2m, well, that would be 4mn. I'll say that again, 4mn. I wish you used different letters. Next, 2n times 1, that's going to be plus 2n. 1 times 2m, that's 2m. And then finally, 1 times 1, which is plus 1. So we've got 4mn plus 2n plus 2m plus 1. Now 4 times anything, well that has to be even, plus 2 times anything, well that's even, plus 2m, well that's even, plus 1, which is odd. Well, an even plus an even plus an even, that's even, plus an odd will equal an odd. So therefore, we have proved it. We have proved that the product of two odd numbers will always be odd. Next. Okay, now last example. Last example says, prove that when two consecutive integers are squared, the difference is equal to the sum of the two consecutive integers. So first of all, let's state what our consecutive integers are to begin with. So let's let our two consecutive integers be, well, it doesn't specify whether it's an even and then an odd, or an odd then an even. So let's let our first one be n, and our second one, well, our next one would have to be n plus 1. Now it says prove that whenever two consecutive integers are squared, that the difference is equal to the sum of the two consecutive integers. In other words, we're going to square these and then we're going to take them away. So we're going to do n plus 1 and we're going to square it, and we're going to take away n squared. Now whenever you want to do this, well, we want to square this bracket, so let's write it out beside itself. And we're going to take away n squared. Well, n times n, well that's n squared, plus n plus n plus 1, take away n squared. So this difference of the squares of the two consecutive integers will give us, well, that'll give us 2n plus 1. So the difference of the squares of the two consecutive integers gives us 2n plus 1. But also the sum of the two consecutive integers, well, if we add them, n plus 1, we're also going to get 2n plus 1. And that's it. We've proved that whenever you square two consecutive numbers and take them away, it's the same as the sum of the two consecutive integers. And that's it.